Welcome to clickmyproject.com. Our product title is fault tolerant parallel filters based on error correction. Let us see about the abstract of our product. The power consumption and speed are the two main challenging factors in very large scale integrated circuit design techniques. Soft error pose a reliability threat to modern electronic circuits. This makes protection against will errors a requirement for many applications. Communications and signal processing systems are no exception to this trend. The computations savings is one of the way to obtain the optimized power consumption and speed. In this proposed implementation is detecting the error and correcting that in digital communication using IR filter used with Hamming code parity checkers. Infinite impulse response is here properly applying to many linear time variance systems. Commonly examples of linear time invariant systems are most electronic and digital filter systems with these properties are known as IAR systems or IR filters and are distinguished by having an impulse response which does not becomes exactly zero past a certain point but continuously indefinitely. In modern communication system it is increasingly common to find several blocks operating in parallel. Recently, a technique that exploits the fact to implement fault tolerance on parallel filter. It has been proposed using of Xilinx software in the language of Verilog coding. So the two improved protection schemes that combine the use of the error correction codes and detected methods is implemented. Next we see about the flow diagram of our product. In this flow, first we give the input x of n, for n is the number of bits of the input data. Then find the d of n using feed forward blocks. Then we added with feedback block. Then we find the y of n output. Then Hamming code with parity checker and the output is a final. So infinite impulse response is a properly applying to many linear time invariant system. Common examples of linear time invariant systems are most electronic and digital filters. Systems with this property are known as IAR systems or IR filters and are distinguished by having an impulse response which does not become exactly zero past a certain point but continues indefinitely. Combined feed forward plus feedback control can significantly improve performance over simple feedback control whenever there is a major disturbance that can be measured before it affect the process output. In the most ideal situation, feed forward control can entirely eliminate the effect of the measured disturbance of the process output. Even when there are modeling errors, feed forward control can often reduce the effect of the measured disturbance and the output better than that achievable by feedback. Next is here about the running process of our product. In this proposed implementation, we check the error correction and detection using of IAR filter and Hamming code parity checker. So in this data we given the first input data, then the data will be getting the output is the same and also the error will be generated and that error will be corrected after the Hamming code parity checker using of that. This is the using Verilog language coding, and in this process this is the output simulator waveform. This is the one part of the output. Another part of the output is the implementation design. In this implementation design we can see the synthesis report. In the synthesis report, first of all the design summary shows the how much amount of LUT is used in this process and how much amount of flip-flops is used in this process, and then what are the input and output bonded we using and corresponding values are given. So in this overall process we using bonded and output is 64, and timing report says the timing summary how much delay is taken to run this overall process. The delay is 3.124 nanoseconds. These are the output data, and main one is the power consumption. This power consumption is calculated using of Xilinx external software tool. So in that tool we we the values are assigned, the parameter values LUT, flip-flops and input output bonded. So those values is entered, then the power will be calculated. And also in the synthesis XST we can see the view RDL schematic waveform. In the view RDL schematic diagram, it shows the what are the input data, what are the output data we get. So open that. So those inner blocks are view. Next one, the technology diagram. In the technology diagram is the same way, what are the input and output, and double click that file, we can see the what are the parameters are using, how much of the scheme, control scheme is working there. So those value, those details are give in this block. So using of IR filter with Hamming party checker, the error will be corrected and also that detected. So overall power consumption will be reduced compared to the FR filters. Thank you for watching this video.